I'd like to welcome you to the webinar Topology Optimization with ProTop, and I'd like to talk a little bit about the news in version 6.0. So therefore I set it up an agenda for this webinar. First, some few words about the presenter, about the company I'm working for. Then let's have a little overview with slides about the news in ProTop v6.0, about the user interface, the brand new session manager, about the improved meshing tools, the shaping optimization, and some other news in ProTop 6.0. Okay, here I have some topics about it. And of course, as the most of you know me, I will do quite a lot of the demonstration as a live demonstration, and therefore I will use a little adapter to show you the behavior of the news and to show you the workflow within ProTop. And at the end of the day, we'll have at the end of the webinar, not of the day, we'll have time for questions. Okay, sorry about this inconvenience about the slides here. So first, the presenters today. It's me, Urs Simler. I'm a CAD simulation expert at the company called GIA Informatik AG. And unfortunately, not in the call. He's right now on holiday in Turkey. My sales guy, this is Daniel Losley. So later on, if you have any questions about commercial things, please contact him. Here are his contact data. A few words about the company we are working for. Company is called GIA Informatik AG. We are right now 31 years old. We are located in the middle of Switzerland, and about 160 employees are working for GIA Informatik AG. GIA Informatik AG is a daughter of a bigger company called Müller-Martini. They have about 3,000 employees. They're also working with CAD, Creo-Parametric. They are producing, after the printing process of newspapers and so on, they're printing, handling, cutting machines. And GIA Informatik itself, they have three topics they're working on. One topic is SAP solution. One topic is IT services, and the last topic is CAD/CAM or PLM solutions. And we'd like to, let's say, have successful customers. Therefore, we do not only sell the product, so we do also implementation, and we'd like to support our customers with different products. In the CAD environment, our main partner is PTC, and as you will see later on, there are also other partners we are working with them, and one of them is CAESS, and CAESS is, let's say, the owner of ProTop, the Topology Optimization Service. So the PLM people at GIA, they are working mainly with the PTC products. And another product is this topology optimization called ProTop from CAESS. And there is also another solution for electrical clearance and creepage analysis for all CAD systems. It's called AutoCrear. And there you can, let's say, analyze this creeping and clearance distance. We're also working with Mentor Graphics CFD solution. Mentor Graphic was recently bought by Siemens. And by the way, we are also supporting solutions from TechSoft. TechSoft provides additional solutions in the PTC Creo environment. It's an Austrian company, and another partner of us is the Software Factory from Munich. Beside that, sales and training and consulting things, we are also monitoring customer system, PDM systems. We have an own PDM ERP interface, and our training center is located in Oftringen. And our team, 9 people, they have about 135 man-years of experience in the CAD PLM environment. So that's all about me, the company, and the environment I'm working in. So let's have now an overview of the news in ProTop 6.0. ProTop 6.0 will be released in July 19. So right now I'm working with a beta version, and in this beta version there is no help functionality in it. The other functionality is, let's say, 97% is in it, but on this version I cannot yet show you, unfortunately, the help file. So if there are customers in the call and they are excited about the news in the new version, and if they want to use it earlier than July 2019, then they can send me an email and I will arrange that you can get, let's say, also a beta version of ProTop 6.0, because there are exciting news in that environment. The user interface looks nearly the same as in ProTop 5.0. There are some, let's say, little things which changed, and I think this user interface is quite intuitive, it's easy to learn, flexible, and it has really an excellent help. Customers who are using 5.0, they will confirm that with nice pictures and really very good descriptions of the functionalities of ProTop. In the new version, we'll see a session manager, new session manager. I really like this manager because topology optimization is not a, let's say, straightforward creating of topology. It's testing around, playing around with different features, and with the help of this new session manager, it's really very easy to control these variants you're creating, the design studies, and it's easy to restart from an old instance and so on. It's really great to work with that. I will not go back to 5.0 because this is a very, very important new feature. And by the way, there are also no new, let's say, small things which change. By the way, when I'm importing, let's say, our input deck, then every volume regions will be selectable. So later on you can remove those regions in order to decrease the size of your models. And also the mesh tools are greatly improved because you don't want to go back always when you have a new, let's say, a nicer model. You want to have denser mesh or another mesh, then you don't want to go back for, let's say, your original FEM system to recreate the mesh. So therefore you have greatly improved tools for redefining the mesh within ProTop. So it's easy to redefine meshes in certain volumes or along some surfaces. This is quite interesting because later on we'll see we can strip that surfaces, and along these stripped surfaces, along the topology cutted surfaces, you can do mesh refinement. Okay. And when you did the mesh refinement, you can also improve the mesh quality in order to get, let's say, nearly perfect stress result within the topology optimization. So at the end of the day, you don't have to go back to the FEM system for doing a validation calculation. To do really, you can validate the stresses very good with the help of this mesh improvements directly in ProTop. With this new meshing capabilities, you can, let's say, cut away the elements you don't need anymore. So let's say the elements which were cut by topology optimization can be taken away to reduce the size of the model. That means on a normal machine, a normal laptop, it's easy to perform with these options very, very big models. And on the other side, you can say, okay, I just want to use the cutted surfaces for nicer shaping optimization. You will see that later on, so you can really smooth in the topology optimization, you can smooth the surfaces, and you will see also the behavior of the stresses. The stresses will also be smoothed with that options. Okay, and when you smooth these surfaces, or then you can also do this shaped optimization of the stripped surfaces. So it's like a fine-tuning of these surfaces, and therefore you will get nearly perfect stresses on your topology optimization. As an example, I have here the GE bracket with normal topology optimization in ProTop 5.0. You'll get here surfaces something like that here. And with the help of the shape optimization, you'll get here that surfaces. And you can see here that surfaces, the stresses here are much, much more accurate on the right-hand side than on the left-hand side. And I think that's a big, big, big advantage of the new version. And when you bring in shape optimization, the components in ProTop are looking like that. So here you can see I have nearly perfect surfaces with nearly perfect stresses, and we're going to have a look at it in a few minutes. When you have these perfect stress distributions, then of course you can bring back later the component to your CAD system with the help of a OBG file. This OBG file is a wavefront format, and the most of CAD system, they can re-import or import this format and create a solid part. Okay, and as I told you at the beginning of the agenda, there are also some additional points, smaller points, where you will find some improvements in version 6.0. When you import the components, you'll see here that on every load case there is or on every loaded surface there will be a face or surface created. You can, let's say, pre-stress or pre-strain, sorry, pre-stained component screws in a direction of a specific coordinate system. And there will also be a support of weighted links. Right now it's supported for NX model, but I think until July there should also be the support available for CATIA, Creo, and SolidWorks model. Okay, and in many places you'll find some nice small improvements, handling improvements in ProTop 6.0. So let's show 6.0, and therefore I'll use here an adapter. On that adapter I will start here. I will fix the adapter up here. It goes up there, this adapter, and I will load this adapter here on 4 places with a certain amount. And at the end of the day, I want to show you the session management with a solution of maybe lattice structures, with a 3D printed solution, and with a casted solution. Now I'm going first for the CAD system right now, because GIA is a PTC reseller. I'm using Creo Parametric, but in other CAD system as Siemens, as CATIA, SolidWorks, and so on, you also have some simulation application, where you can build, let's say, a simulation model. and I'll show it right now, the simulation model creation from scratch in Creo Parametric. I'm starting here just with a constraint. I constrain it in all direction, and now I'd like to load, let's say, this part here, but I don't want to load all of the components, just these 4 surfaces. Therefore, I'm going to create here in the Refine Model tab a surface region with an internal sketch, and I want to sketch it here, okay, and with the help of a rectangle. Okay, this one here, here and here. I'm dividing, let's say, those surfaces here. Okay, they're divided right now. I can select all of them. You see it here, and I'm going to load it in Y direction with 100,000 kilonewtons, this direction here. Okay, this thing is loaded, and by the way, I want to, let's say, define here a so-called fixed region. So topology optimization should not be allowed to take away material in that blue region. Therefore, I'm creating here on this plane, I'm creating a volume region. Okay, again, with the help of the rectangle. I'm doing here that volume region. The length should be 90 millimeters. And I wanna, let's say, cut away in both directions through all. And this volume here will be, let's say, assigned, or I'm going to assign this material to that volume. I have 2 similar materials here. Only difference here is this naming, underlined fix, will be known later on in topology optimization as fixed material, which is not allowed to take away. Therefore, I'm assigning this fixed material to that volume here. Okay, that's nearly all I have to define. I'm defining an additional analysis. I call it here maybe ProTOp V6. Okay, and I'm including these constraints and load sets. You can assign as many load sets as you like, and you can also define as many constraint sets and combination as you like. Okay, and of course at the end of the day I need a mesh. This mesh is much too coarse, therefore I'm setting some mesh controls on the whole component, and the mesh controls should be 8 millimeters, and I'll get quite a dense mesh here. I'm meshing the part again. I can visualize this mesh, and now I will save this mesh here as a input file for ProTOp. Okay, linear elements, and I'm writing down this, where is it? This FNF file here, down there. Okay. In, let's say, the version in July here, you can press this button in Creo Parametric, and then everything will be done automatically. But let's say the other CAD systems are working the same thing to share the FEM, so the FEM input deck with ProTOp. So this is the manual way I'm showing you like now, and therefore I will bring in right now the ProTOp interface. This is ProTOp interface of V6.0, and I'm just creating a new project. You'll see here I wrote out here that file, this FNF file, and I'm going to use that FNF file, and I'm importing all that stuff. And this is also a new thing down there, the generation of surfaces and the improvement of the mesh. And as a first thing, we're going to have a small view at, let's say, the interface here. You can display, on display, comment, graphic lines. You have a logger, here the help, and here is the session manager, and also here you can say, okay, I want to save a specific picture, of the model which was created right now. So my component I'm going to create should be a symmetric component. Therefore, I'm going for my optimization model. And I'm applying here some new technology constraints, and they should be from type plane symmetry. And only, let's say, this volume region should be symmetric in x direction. I'll see here. Okay, this is the x direction, this purple plane there. I'm taking the same technology constraint and I'm doing a copy of them in, and by selecting the z direction, my component will be mirror symmetric also to that plane over there. I'm taking right now in my session manager the original model and I say, okay, I want to make a copy of them. So in that copy, all these technology constraints are stored, and I can, let's say, use a useful naming for my components or for my variants. I say this is initial, and this should be maybe at the end I want to create, this is maybe lattice 1. Okay, I delete that one. And if I do not, let's say, define any other things, I could just go in and start my topology optimization. As before here in v5.0, you'll get information directly about, let's say, stresses, von Mises stresses, main stresses here, or displacements. Okay, and during optimization you can stop, run, optimize your components, direction of volume or direction on stresses or maximum displacements. You can also bring in, let's say, eigenvalue analysis. Right now I'm stopping that thing here. Okay, optimization was stopped, and I want to go back, let's say, to my optimization model, and I want to create a new configuration. I want to maybe use here a lattice configuration. So I'm creating here a lattice configuration. Which volume should be treated with that lattice configuration? And if I take this type of lattice here, a rod, then it looks like that. If I'm taking a honeycomb structure with maybe a specific sizing here, 50-50, that's the size of the honeycomb. I'm rotating it a little bit, and this here is, let's say, the size of the bars. And if I type in 0, if I'm going here for parameter 1, it shows me the maximum configuration of that lattice. If I'm typing here maybe 0, this is the minimum configuration, there is nothing left. And here I can type in on which size show I want to start. So I want to start with that bars here. Okay, and this configuration is right now also stored in my model, and if I'm going right now for topology optimization, and if I run that cycles here, you see, okay, it starts with that size, and you'll see, okay, there is already cut off here some volume. So this is not the case or the variant I'd like to work with it. I'm going to abort that guy, and I easily can go back for my FEA optimization model, and I say, okay, I want to use not the current design. This is current design right now. I want to use, let's say, the configured design. And the configured design is this guy here. I'll see, okay, the bars in that regions are still there. And I make this configured design now current. Okay, and when I'm starting right now my new topology optimization, okay, it starts with the bars. And I'm going to define which volume I'd like to have, 33% or even less. Of course, it must be within the range of my configuration. I typed in right now 19%, and as we can see here, the bars in the middle, they will be very, very small. They might disappear depending on my volume target. I'm typing in right now a volume target of 16%. Of course, it would make sense to have a little bit better legend distribution. So I'm decreasing here my legend levels. And you can see, okay, topology optimization is cutting away here the bars. Of course, my density of my mesh is quite bad. Therefore, I'm going to stop this calculation and I'm bringing in a new mesh refinement. I'm just going here for my mesh refinement. I'm going to analyze that thing, and I just want to cut all elements which are above 5 millimeter size, but I don't want to spend too much resources. I'm limiting the solver RAM to about that size, and I'm redefining here my mesh, and he told me, ProTOp told me, oh, I created a new session for you. So it's easy to go back to the course model, use the course model, or use, let's say right now, the model with the denser mesh. So right now I have the dense mesh. I'm going back for my topology optimization and I rerun it. And maybe I'm going further down with my target. Right now I'm working with a volume target. Again, stress calculation will be done, and depending on that stress calculation, which is done right now, ProTOp is taking out the elements not needed or the bars not needed, and it's increasing maybe the diameter of the bars which are heavily loaded. And of course here we'll see the cycles which are running, and we can see when we zoom in, right now we have more or less enough elements for a bar to be optimized. Of course, in reality, when we are dealing with these lattice structures, we should be a little bit more patient. We should use a little bit more of elements to have perfect results. But for demonstration reasons during that webinar, I think it's okay, and you'll see, let's say, the behavior of the session manager. So I'm satisfied with my new variant. I'm going to stop the topology optimization, and I'm just going back for my home tab. And on my home tab, I can see in the session manager, oh, I created quite a lot of instances. This is the instance, let's say, with the coarse mesh, and this here, maybe I can rename it. This lattice 2 with maybe dense mesh, something like that. So later on, I know what's behind every session. So I'm going back here for my initial component. I'm activating that one, and I'm creating a new instance of that here, the application. Okay, I have now my origin model with technological constraint in it. This two plane symmetry constraints, and I want to create here a model for the 3D printer. Therefore, maybe I call that guy 3D printer 1, and maybe this is first the coarse mesh. Okay, and I'm going again for my topology optimization, and I rerun that guy, and the target should be maybe 30 somewhat percent. It's starting here with the initial design, my design room, and it's cutting away the elements depending, let's say, on the stress level. Here I just can go in and decrease the stress level of the legend. And when I'm looking from that side, I can see the stress behavior. There are also capabilities to create some cross-sections. I created here a cross-section. I can move that cross-section in different direction. Here it's also possible, let's say, to do the element movement more aggressive. Okay. Here we see we're right now on 65%. I'm going to take out the cross-section again. And we see, okay, this is getting to be a nice idea. How can I, let's say, modify that guy with the help of a 3D printer? Again, here I think now the elements over a bar here are getting, let's say, around 3 elements over that bar. That's let's say not enough for topology optimization with H elements. Therefore, I'm just pausing that thing here, and I'm increasing again here with my capability of mesh refinement, and I'm increasing here the number of elements. Again, I don't want to spend too much time here. I'm refining the mesh. A new instance will be created in my session manager. And I can really easy play around with my ideas, with my models, and it's very, very easy to control it. The only thing is here, I would suggest rename the models in a meaningful way because you soon have too many instances, or delete the instances you don't use anymore. So I renamed that one, and now I'm just going for optimization again. I'm rerunning that one, and now my target should be, let's say, about 15%. Okay, it's taking away the topology from the coarse optimization. It's taking the dense mesh, and because only 30% of the volume is active, and with more elements inside, the time, the optimization time is still very, very good, and the results are quite good in order to have nice stress distributions here. Okay, I'm looking from that side, and I can see my stress distributions. Here I can be a little bit more aggressive with the cutting. Okay, going a little bit back with the cutting. It's really playing around with your model. So now it's bringing in some holes. The stresses will increase here. I can, let's say, change the legend levels of my stresses. Okay, and here I can see a very interesting solution if I have a 3D printer at home. Okay, if I think, oh, this is too small, this component in that area, I'm just increasing the volume again, and ProTop is adding some additional material. Of course, here that bar is getting a little bit too small, too less elements inside. I could increase again and so on. But let's keep it like that, and let's try to create the last instance. I want to create now instance which can be casted. Therefore, I'm going back for my Home tab. I'm going back for my initial solution. I'm creating a duplicate. I'm renaming it casted course, something like that. And I'm going here for my optimization model. Current design, yes, should be that one here. Okay. And I'm bringing in on my FEA model, on my optimization model, an additional constraint. And in that case, I'm copying that one and I want to do a casting, which is called bi-unidirectional open. I think here I have the capability to bring in a draft angle. It should be 5 degrees. I'm closing that one. You can also suppress or toggle these constraints. If you do not like to use it for an instance, you just suppress it. And then we're going back for our optimization thing. We are starting again from, let's say, scratch with the course model. And right now, when we are taking away, or ProTOp is taking away the material, this part will be with a draft angle of 5 degrees, and we should be able to cast that part. So let's change here maybe the views. And you can see it here, yes, from that side here, there should be the draft angle here. Minimum it has to be 5 degrees. I think we can see it quite good. Here on that holes which are here created, here we have the draft angle. And of course this is the symmetry line. Okay, it's already open right now. Okay, maybe let's decrease a little bit the aggressivity. Okay, we are on 40%. We're going down a little bit more. So the component will be also cutted in that way. Okay, and now we'll see, okay, this guy can be casted. Of course, we want to have at the end of the day, we want to have nearly perfect surfaces. Therefore, I will do the mesh refinement again. I'm stopping here, the optimization right now, FEA model, do the mesh refinement again, analyze it, and do the mesh refinement around 5 millimeters and a certain amount of RAM. Going to redefine it, new instance will be created, and now it's getting interesting for the casting companies. Okay, mesh is here. Okay, and I'm going for topology optimization again. I rerun it, and now my target is, let's say, around 70% of the initial volume. Now I have a quite dense mesh. Of course, in practice, I would do it a little bit or 50% denser, but in order of, well, because of the web demonstration and the time, my mesh is, let's say, not that bad, but I could do it perfect within ProTOp if I have enough time. So topology optimization is done right now, and it should start with this 33% level. I can see here it's still running. Okay, and it should now display my stresses, hopefully. Yes, now starting. Oh, this is quite nice, the mesh. Okay, now the stresses are displayed. And at the beginning I'm going to cut away a little bit more aggressive to get the results. In the meanwhile, I'm checking here the question panel. Right now there are no questions at the moment, so if you have any questions about anything, please write your question in the question panel. Okay, in the meanwhile, we are here on 23.4%, and we can see here a quite interesting solution which can be casted. I want to have a little bit more of volume here. I'm increasing here the volume again, maybe to 23%. Okay. and I say, okay, this solution is satisfying me right now. Or let's wait another cycle. Okay, this looks quite nice. Here we can see, okay, the target convergence and the stability of the convergence. Okay, it would take maybe 2 minutes more, but because of the time, I'm going to accept that instance here. I'm pausing that guy, and now I want to, let's say, use these new capabilities of, let's say, the mesh stripping and the shape optimization. First, I'm stripping the mesh, so that means with that option here, I can cut away all the elements which are not visible anymore. That would reduce the size of my model dramatically. And on my laptop, I'm using a 3-year-old laptop, I can solve quite big models. But right now I just want to deactivate this element, so I'm just stripping it here. Okay, and that means right now if I have that stripped shapes here, I can go here for maybe first for mesh cleaning to take away or improve the elements with a bad quality in order to get a nice stress result. And with the shaped optimization, I can, let's say, smooth the surfaces here. Right now, you can see here maybe the surfaces are something like that here. And this capability smoothes the surfaces. And it also keeps an eye here on the stresses, on the geometry. So it's not topology optimization we are doing right now here. We are just moving a little bit the nodes in order to get a better stress distribution. And this will smooth the surfaces dramatically. Of course, within 3 minutes, you just reach, let's say, 50%, but if you spend 20 minutes, you will have nearly perfect results. And you can see down here, okay, the smoothing is getting much better, and it's also capabilities inside. You could say, okay, I want to shrink my model a little bit. Now it was going in the other side. I want to shrink it a little bit. Okay, and it will, now you saw the shrinking, and if it will move a little bit my components in order also with the help of the shrinking thing to have better stress distributions. Okay, here you can have an eye on, let's say, more geometry, on the stress all over the part, or on the peak stresses in the part. But in that area in shape optimization, we should use, let's say, a little bit more time to get perfect results. But the other thing I'd like to show you is the mesh refinement along the stripped surfaces here. So right now along the stripped surfaces, zooming in here a little bit, I have yet, let's say, quite a lot of elements, but I want to have much more, let's say, for the final solution. So right now I'm just remeshing. Right now I'm remeshing just the surfaces. Before we always remesh the whole volume or certain volumes itself, but now I'm remeshing only the cutted surfaces, the stripped surfaces. We have much more elements inside, and with this much more elements here, of course I can do again shape optimization, and with that help, of course, I have more elements inside. I will get nearly perfect results. So the need to bring back the model to an FEM system and to do the validation calculation over and over on a transferred model will be decreased dramatically, because right now with that many elements, I will have nearly perfect results. Okay. Now we have here that thing, and now we should be able to see the results again. Now we have the results. Of course, I could do, let's say, the shaped optimization more, but because of time, I'm stopping it here. And I want to show, let's say, the transfer back to Creo Parametric in that export tab here. I'm creating some surfaces. Okay. Now I can, let's say, smooth surfaces again in that area. In that smoothing area, let's say the stresses are not taken into account for that smoothing. It's just smoothing the surfaces without looking at the stresses. So I'm checking first the component. I'm expanding, let's say, this bandwidth here along these cutted surfaces. Okay, I'm going to select them and I can remove now, let's say, some peaks. Okay, I'm going to redefine the triangles a little bit. I'm going to smooth the surfaces more and more. I can simplify the surface a little bit more, smoothing again, and it's just moving a little bit, smoothing that surfaces. When I'm satisfied, I'm exporting that surfaces. Okay, because I want to use that later on in my CAD system. First, maybe I'm simplifying a little bit and I'm exporting that surface as an STL file to my working directory of Creo Parametric. Oh, this is maybe live STL. Okay. And I want to show you the second possibility to save it. To export that surface, this is the so-called OBG file. And this is a wavefront surface which can be imported in nearly all CAD systems. So right now I'm back in Creo Parametric. I'm testing the first variant. I'm just opening here the STL file. This one, oh, Louis V. Oh, okay. Anyway, let's take that one. I saved before, and I can see here, let's say the STL file. This can be maybe taken as a help for recreation of the data, or can be sent directly to a 3D printer. And as a second thing, I'd like to show you the option with the OBG file. I created a new part, and here with the freestyle feature of Creo Parametric, which is part of a standard license, I can take these surfaces. Oh, the limit is too big. I made it wrong, because before I have to export it, sorry for that, I should simplify a little bit, because there were too many triangles on it. Oh, stupid guy, Mr. Sin. Okay, I simplified it, and now I'm going to export the surface as an OBG file. Okay, let's call AAA. Okay, and back in Creo Parametric, here under Shapes, I'm going for importing the mesh, and this one is the AAA. Okay, and this should be this should be able to be imported. Sorry for that. But it's a live demonstration, as you can see it right now. Okay, this component is imported. This surface feature, we can also manipulate that surfaces. We can build a volume out of it, and we can use that for, let's say, further analysis or what else. You can see it right now, that model. I'm looking maybe from that side, and you can also select here, that's Creo Parametric, that surfaces. You see them, and on the freestyle you can say, okay, I want to have it here sharp corners on that surface, or you can delete some surface patches. You can do quite a lot with that stuff. You can cut it, you can take them away, these surfaces, just in order to recreate that part. But that, let's say, closes the loop of topology optimization, and also it closes quite soon the webinar, because I'm at the end of my live demonstration. I started, let's say, with a component in cryoparametrics, set up the constraints, loads, and so on. Then I went to topology optimization. I did several instances here with the help of the session manager. And I think that's a very, very important thing, because topology optimization is not a straightforward input and then you get an output. It's really playing around with instances, and that supports in a great way, let's say, the creation of topology optimization components here. Then we did that one here. We were having a look here in the optimization path about this new capabilities, and now we brought back the geometry to cryoparametric. It's here. Okay, and later on we can do, let's say, some further simulations or further disciplines with the help of that models. That brings me back to the slides here. We saw here this adapter demo. For the live demo of the G bracket, there is no time. It needs more time to show all that thing. But just to inform you, this topology optimization, maybe for people who saw the first time this ProTop thing, is also available for nonlinear studies. So you can bring in some contacts, you can bring in some plasticity, you can do with the pre-straining feature, pre-stress screws. And by the way, we saw not, let's say, the shell capabilities. I showed you a little bit the lattice capabilities of ProTop. And I think it's really a great tool for engineers to bring topology optimization in your development process. And it's not rocket science to be able to perform this analysis here. Okay, so this brings me to the question and answer session. So are there any questions right now? So please use the question panel in your tool. Right now I can see no questions. Is there a direct link between SolidWorks and ProTop is questions. It's not, let's say, that direct link as I tried to explain to you. We know here from cryoparametric. So in cryoparametric, I would say here we have, let's say, this direct link here. So we can push the model directly to ProTop. In SolidWorks, you have to go to SolidWorks simulation, setting up the model as I showed you here in that demonstration, and you just have also to run or to write out a certain format, and then you go also back for ProTop, and you're creating a new model with the help of that input. Okay. Then another question is, why is the module topology optimization within cryoparametric not sufficient? This is a dangerous question. for me, because we are a PTC reseller and reseller of ProTop. But when you're going to have a look at the topology optimization in PTC solution, there you just can, let's say, make the, or let's start something like that. I mean, the advantage is you're totally integrated there. The advantage is when you have the topology optimized shape, you will get, let's say, a nice surface. But this surface, I would say, you cannot use it for a casted part, as we cannot use the OBG surface for really the casted part. At the end of the day, I think you have to recreate a very precise surface with standard features in the CAD system. So let's say the first directly copied surface from topology optimization is not suitable for a perfect construction. And therefore in cryoparametric topology optimization is you make an input and you start the application, and then you just can wait, and at the end of the day it shows you a solution. You can accept it, or you can accept it from scratch again. Here in ProTop you can play around, you can stop, you can go back, you can go forward, you can use lattices, shells, and by the way, lattices, shells are not available in cryoparametric, but we can talk, let's say, offline on that topic. And then Creo is pushing new partner for Topo in Creo 5. Is it possible to compare both? Of course you can compare it. You can get the test licenses from PTC, and you can also get a test license from us, so no problem. Send me a mail, contact me, we can arrange that. Then let's have other questions. There are no more other questions right now. So yes, we are in time, so it's 2:30, so we're just in time. So that brings me, let's say, to the end of the webinar. I'd like to thank you for your attention, and I hope it was worth to spend 1 hour with me and having a look at the topology optimization. And as I said before, if you have further interesting on that solution, please contact me. There is also no problem to make a customized demo for your company. If you really are interested, there are some testing licenses. Just call me, call Mr. Losley. We would appreciate you to have more questions from you and to show you more capabilities of this ProTop version. So thanks again. Having a great afternoon. Buon pomeriggio. A bientôt. Auf Wiedersehen. It was a pleasure for me to have you on board. See you soon. Bye.